this needs like a bit of extension, and maybe we'll make this about things and we'll give an interview a table and actual this document's just built on those things, but it's built into a lot of it. Maybe what we handle. So yeah. But anyway, laptops, because this information is just here. So, and this I've got, that's there's a lot of JS there, which is but this will actually, even the guys who did this,
okay, good morning all. Make a start. Today I'm going to go through the scheduled lecture for semantic knowledge for technologies and things to the web, but also some help with the assignment on task 3. I think I've done more than enough on task 1 and 2, the programming side. In fact, some of the feedback I'm getting is saying you're giving too much help out here. Others may disagree with that, but there's a lot of helping you with tasks 1 and 2, the coding ones. I thought I'd spend 15 to 20 minutes just on tasks 3, the bit about where you're going to be designing a system to, in this case, a lawn sprinkler system for it. So I'm going to sort of work on that. By the way, this week, the full-time students, as opposed to the DTS people who are in here, this week is the midterm feedback, where we ask you for your views on how everything's going so far to it. We're doing it sort of in labs, but you can do it at any point. There's a link just here at the on the announcement section, course information section. And if you follow it, you don't have to fill a paper one in. It's an anonymous survey, just little tick boxes. Whether you think this material's too much, just right, or whatever, whether it's all too easy, those sorts of things. And then finally, a couple of text-based feedbacks for if you want to say something that you think is good, or something that you think could be improved. People often treat these surveys, or they're often sort of viewed as basically a complaints procedure, and we all we get. People who say, well, quite right, I want to make a sort of point about it. And people who are thinking things are just fine, very happy with how things are going, they don't want to filling it in because they're sort of happy. We'd like views from everybody, basically, as many as we can. Yesterday I had something like the labs equalled about 50 people that I asked to give this survey, and at the end of the day we only had 22 coming back out of it. So we'd like as many to fill this in as possible. We want a good survey response because we're going to act on these. And if people are saying, oh, we don't like this, then that thing might come out of the course. And if people do like it, we want you to say so for it. So big thumbs up to anybody who has filled it in, or is going to fill it in, or what's called the paddle of rebuke for those who aren't doing. Right, that's the, I made this for another session. So if you're thinking about not doing it, or don't do it, you get the old paddle of rebuke. You won't even go down smaller. So you get that way that you're all clumping around the head with it, saying, please give us some feedback for this. So just gave me an excuse just to do this toy out of the cupboard. But today, I want to give you some idea about feedback. Sorry, not feedback, some process on starting off the task 3. And to that end, I've got some loaded up to Moodle already. I'm not going to email this out. I tend to often sort of put things out on the forum and send them out. Again, some of the feedback that I'm getting is we're getting too many emails about this and too much help. Don't know where to sort of work with that. But there's this sample node layout available, this diagram that I'm just about to put up. So if you want that particular thing, you can. It would be a good idea to remember as well some of the sample nodes that we've already seen. For example, this is the Honeywell Evo Home radiator controller. This has got a little connection on the bottom that fits on top of your radiator to sort of turn on. It's got a little LCD display. There's a manual override to work with. Power supply at the back to put in a couple of batteries. Inside the actual device, you'll find the processor to control all this. Now, this is a fine example and a very typical example of a node to it. I've noticed in some of the questions coming in that people aren't really understanding what a node is. And this is what you're going to be designing for this task 3, is a little node network for this sort of sprinkler system. And this is actually very similar to the type of node that you want for the sprinkler, we'll see. This has got a motor in it, it's got a manual override, it's got a power supply, a little sort of output LCD that you don't need, so it's not all the same. But in general, a sort of sample, like what I'm anticipating for this task 3, or what you're being asked to design, is like a smart sprinkler system to sprinkle your lawn. Like, presumably that rich, you've got massive lawns about this sort of place or something. Although we're not designing it for yourself, you're designing it as a concept model that perhaps might get built at some point, where you'll have multiple sprinklers dotted about the property for it, with hopefully a water supply going to them, possibly dug into the ground, I don't know really. But the sprinkler system is, or the sprinkler nodes, are the things that are quite similar to something like this to receive. They all need to communicate with a centralised hub to sort of control these, and I'll just sort of talk about that as well. Again, some sort of feedback received so far, and I appreciate as much feedback as possible. Some people were saying the lectures don't seem to have anything to do with the assessment or with the labs. They don't sort of see the link. The relevant lectures to do this task 3 are lectures 2, 3, 4, 6, 7, 9. Quite a few things there with this sort of information in it. Lectures 2 and 3 talk about what nodes actually are, to get the understanding of what a node is, what the components are, and I'll bring that up in a second. Lecture 4 talks about how the nodes might communicate, the network protocols they might use, like CP, Bluetooth, whichever sort of technologies like that. Today we're just having a look at data wrapping protocols, where you might what sort of format the data might be as you go between. Next week we're going to have a look at a bit more in depth at what MQTT does. You're already using it for task 1 and 2. We'll have a look at it in a bit more depth there. And possibly, if you wanted to introduce voice control into this as an extra, we've got a section on writing voice control applications using Amazon Echo or Google Home, that sort of thing. So yeah, there's plenty of relevant material going to be about there. And just another example, one of the things that I passed around the other week was, it's sort of hard really to see much on it here. This was the this was the August lock mechanism, which fits over a spindle coming out to be locked and basically turns one way or the other to it. not necessarily in a sensor network, but that receives an instruction from, say, a phone to turn itself. That's a node for it. It's got its own processor in it. It's got its own actuator in this case. It's only got an actuator, the actual sort of motor for it. It's got communications built into it to sort of put in there. In this case, it comes in a nice little case, like your other radiator controller comes in a nice little white box or whatever to put on. Honeywell aren't the only ones to do this. I'm only using this because I've got these things dotted around home. They're done also by companies like Netatmo, the TADO or TADO, TADO. Lots of people are now coming out with these smart home systems for controlling your heating system for that. And as I say, that will be somewhat similar to this. You can almost replace these sprinkler nodes with radiator nodes to be sort of working with as an idea. And that's one of the reasons why I gave you a node layout for the Honeywell system, for the home heating system. You'll find that as part of the assignment, just to give you an idea of what's going to be in there. So what would these sprinkler nodes consist of? Well, going back to lectures 3 and 2, you sort of had a look at those. They explain what a node is. And a node is a self-contained unit that's got a processor inside it and some actuators and sensors attached to it, depending on what that node's supposed to be doing. It may be just actuators, it may be just like a motorized valve inside it, or it might be a light that's coming on, something that's doing something. It may have sensors attached to it. Again, this thing, that has an actuator for the motor. It has an actuator for the display. It's not proving on at the moment for it. It's got an actuator, a sensor for the turn on. So you can sort of manually set the radiator or manually sort of turn these things on. It'll have a sensor inside it for temperature, because the radiator is just like a normal thermostatic body. It turns on when it reaches a certain sort of temperature for it. Other things that the nodes have, so they'll have a variety of things. I mean, if this is, say, a sprinkler, then put a water supply in, it's going to have just like a motorised valve to open and close for that. You might have some optional things you could think of, like an on-off switch. Actually, that's classified as a sensor, I guess. Just so that if people wanted to, if they're walking by it, they can manually turn that sort of thing on for it. Sensors in there, again, sort of optional. Either it's just going to be driven by when it's told to turn on, or you might think of things like, what about a soil sensor that's detecting when if it's pushed in when the soil's particularly dry or something like that, or temperature sensors for it. But the whole node, like a self-contained unit, would have this sort of processor in it and some way of communicating. Now the processor is going to be a small scale thing that each one of these, both of those will have a processor in it, but it's not a processor like, not a Mac inside it, it's not got it's also some big Intel CPU unit, because they've got very little work to actually do, low-powered work. All they're doing is instructing the motor to open and perhaps doing some communicating. There's no screen displays to handle in these things. So it only needs to be a small-scale processor. So the processor that you may be sort of thinking of using, something like a Pi Zero, or a Raspberry Pi, or this BBC Bit or Tinkerboard. Have a look at what sort of processors are out there. Which one might you recommend to put together with this? It will need to be able to communicate. This sprinkler system is supposed to be sort of you sort of dot these around your lawn. And you're not going to run communication cables to them. You're not going to run LAN cables out on your lawn to connect to each one of these. So there'll be some sort of wireless communication built in there. And similarly for power supply, you're probably not going to run a power supply to each one of these. They're going to be self-powered. So some sort of battery thing in there to run it. The comms, you have to decide, well, what sort of communication do I want to do? What's available to me? What's the best sort of communication to do? And this is where your own design's coming into it. And that's where we're covering in that lecture 4, different network protocols, the different power requirements of them that you might use, Bluetooth and Zigbee and Wi-Fi and other sort of ones to it. And you'll see charts of the relative length of time that each one takes to do it. You'd have to think about how much communication are these things going to be doing. Are they sort of likely to be working 24 hours a day and needing to communicate 24 hours a day, or just 1 or 2 times a day, or even just once a day to sort of turn on? So think about the power supply, the comms in conjunction with that to work with. Like the Honeywell system, or like other sort of radiator systems, yes, these act as these like the nodes over like the sort of sprinkler things, but they don't connect to the outside world. They're not powerful enough to make, say, a Wi-Fi connection or a network connection out to the internet, if you like. They normally work in these sort of sensor networks through some sort of hub node. They communicate with that hub node over a relatively short distance, depending on what your network protocol can cope with. So that's something that you'd have to sort of specify and think about for it. Well, that hub node will be the thing that receives the signals and then transmits them or makes them available to the internet. So that hub node will then be connected to your router or gateway to the net. So your hub node, that's controlling the sprinkler node, sending the messages out, relaying the messages through. It will probably have a different power supply because that's the sort of thing that might be. I mean, it might be in your house, it might be in the garden to it. It might be battery powered, depends on, as I say, whether or not it needs to be continuously available or sort of transmitting Wi-Fi to it. So you might talk about whether it needs an actual power supply for it. But it's not something that's going to be attached to the actual sprinkler system itself. It's not part of a sprinkler node. It doesn't have that sprinkler sort of part to it. Now, if you compare that, say, with what was given in some other earlier examples, back in lecture 2, there was some information up there that I sort of talked about at the time about these commercial IoT nodes, for things that are already out there, like this Evo system, Evo Home system. The nodes dotted around the radiators, these motorised valves in it. They work together with that thing behind that little display monitor. That's the centralised hub for it. So in terms of your home, they have that centralised hub to talk to, and then you have a little control unit that, again, sort of talks to the hub for you to be able to interact with. But in the background as well, there may be an actual app. Well, there is an actual app to sort of work with. So that heating control and replacing this radiator valve, very easy to retrofit on it. There's a power supply. It's got its communication built in to it. There's a centralised gateway connected to the internet. It's what's called a star network in terms of broadcasting them out. It's not another type of network like a mesh one. It's app available, a few sensors, actuators built into it. There's other ones out there. That's a nice one to work with, if you like. And there's a different one about how it might actually connect together. in that you've got that star network where the centralized hub talking to the individual radiator valves, that then talking to a gateway to an internet connection. Because you can have that left-hand side just as a standalone home system. It doesn't have to connect to the outside world. That's like an add-on that they sell you for it. I would think normally you might want that centralized node and the gateway node built into one. Something that might have a network cable in it to sort of talk to. And how your app goes through. Now that's the sort of diagram that I'd expect out of a sprinkler system. I mean, to explain what the individual components are, what a node is made up of, like what's in one of these nodes, and to sort of hopefully try and price one of them up from it. A bit more on that just in a second. There are some other examples in that set of notes. One's on, say, Philips Hue, works in a similar way. This is just actuators in their bulbs. They don't have any sensors as such in them, but they have a hub that they talk through, and the hub is actually plugged into your network directly, into your browser directly. So a sort of diagram for that. And again, these are all available to help you sort of work with this and develop the task 3. They talk to the hub directly, and your hub's connected via a LAN cable to your router. That's just how they've designed it for it. So the hub's doing the controlling, the light bulbs themselves, they're just sort of lighting up. They use a different type of network. They use one of these mesh networks. They're not all necessarily connected directly to the hub, to it. They can connect to each other because the Zigbee technology that they use for communication only works up to, say, 30 meters, 50 meters, whatever, but a set distance. And if you want them to go further, you don't want to be restricted necessarily, or have things like walls that might restrict communication for it. So these bulbs can also retransmit data. They can sort of pass on messages between each other, and you have this mesh network. Now that was a thing that came out again in that networks lecture, for it, so lecture 4. So there's a bit of extra background theory in that, if you like. Their power supply for those nodes, the lights themselves are nodes. Their power supply comes from the plugged into the actual mains itself in the ceiling, wherever you sort of screw the light bulb into. And in the bottom they've got this processor, and you know, to be able to sort of receive network signals and pass them on, or activate the light, or dim it to whatever values you like. So I would say there to sort of have a look at some of these commercial nodes and how they're sort of connected, to sort of work with on that. So that commercial IT node should sort of help you in the general lectures. There's a student project of someone who's doing an environmental sensor and the sort of data type to sort of work with. And all those diagrams, there's a sample collection of node layouts, sensor node layouts available there. So there's some sort of background material. Here's a sort of idea that you might want to use. Now, title at the top, a sample layout, but others viable. I did send out on the weekend some sort of guidelines, again, how you might progress with tasks 1 and 2. And I got a couple back saying, well, I started doing it a different way. Well, that's fine. These are just an idea to it. It's not the only idea. And you know, I'm trying to present good ways of doing it. You may have an equally good way. I'm more than willing to give you some formative feedback on what you're suggesting to it. Now, the formative feedback I'll only give once per person to it, otherwise I'll end up incrementally feeding you back on every piece of development that you do, and I'll be seeing you every day of the week that you do another sentence in it. So I'm offering to give some formative feedback to you know, on a once basis. That's different to help. Help for how to share a message and where am I going wrong sort of here, that's a different idea. But this is just a suggestion for how you might start it. You may have your own sort of way of doing it. I don't want you to go away from this and say, oh, it says we have to use Zigbee, it says we have to use Bluetooth for this. The idea is to come up with a viable proposition yourself. And this might just give you a start-off point. Now the comms for this, these have got to communicate with that hub node. Now some of these processors do have comms built into them. They may have, say, Bluetooth already built into it, some may not, and in which case you'll need to add a little comms module onto it. So it may involve a bit of research, and that's half the point of this particular section, into alternative processors. Just for example here, what I just did a quick Google for 10 minutes ago was Raspberry Pi alternatives for it. And we get a whole sort of raft of different approaches to that. And then I just sort of selected one example there. The top 12 Raspberry Pi alternatives for it, and sort of working down different types of board, what their qualities are, what their different attributes are to sort of work with. So a bit of looking into the different processors that are available will be sort of beneficial here to it. Some of them very cheap to develop. The Raspberry Pi, even a Raspberry Pi, which is a bit sort of overpowered for individual sprinklers, but could sort of do, depends on what it's got on board to it. They were only sort of 30 quid for it. But there's much smaller ones. The Adafruit, the other one that I mentioned there, the BBC Bit. The micro bit. I might also, I don't want to jump onto the link straight away, but these are some tiny little processors that you might sort of use, that you might sort of reject them, but you're going to be having a look at and deciding which particular processor you want. It may be that it needs a Zigbee module working with it, something to allow it to communicate. If you're thinking about using Zigbee or a Bluetooth module to work with. So you might look at these Zigbee modules that work with your particular processor, that can sort of work sort of side by side, because you're trying to, in the end, build up the equivalent of one of these sensor nodes for it, that can do all these sort of tasks inside. So try and find something that's compatible to sort of work with it. You might also want to look at, well, what's commercially out there already. Smart sprinkler systems, which sort of commercially available ones to work with. Now, there's not many in this sort of field that we're proposing, with multiple sprinkler nodes dotted about the garden. There's quite a lot that just turn your water on at a certain time, that basically work at the tap end and turn one particular sprinkler on. But if you sort of take a look down, you might want to look at lawn sprinkler systems. There's even sort of guides to the 10 best ones about for it, or following through some of the ones for the best ones here. I'll just sort of come up. I mean, there's sort of people who are renowned for sort of garden maintenance, if you like Hoslock and Gardena. They do smart sprinkler systems for it. Let me know unless I agree if not. I will. This ratio was one that I've sort of come across, and you can look at what the sort of specs of some of these are. That's more like the sort of hub type system for it.
I was going to bring up one of the other ones. Let's bring up, say, the hose lock one. Well, there's an additional one I'll do. That's just available there on Amazon. This is one that's, yeah, it is sort of controllable with an app, but it's one of these ones that just basically turn your tap on. Right. So it's not adaptable into having multiple sort of sprinklers dotted around that you can turn individual ones on for it. That's just got a module that you can tap into from outside for it. Says it is flexible irrigation, but yeah, flexible irrigation that's just one supply to it. If I put one of the hose lock ones there, I'll just quickly bring up that as a last one. No, they're not the smart ones. One last try. They do one. Not immediately coming up, but you might look at hose lock as well as being another alternative. So there's quite a few places that you can get this background info if you want on it. A lot that I've supplied in lecture material and sort of explicit diagrams like this we sort of work with. Another thing you might sort of factor into the price is an actual case to put it in. Presumably it wants a waterproof case if this is sort of working with it. The prices that you come up with, I mean, we're only asking for an estimate, and it's a conceptual model. You know, you're not building something that's a commercial thing that you go out selling the next day. The idea being that you come up with something like this, you take it along to your Dragon's Den or something like that, or your Kickstarter campaign, and get some sort of funding to get one of these sort of systems built. Right. You just sort of putting together a conceptual model for the whole system put together for it. So that diagram's available on the Moodle page if you want us to use that. But you don't have to use it. It's just, as I say, an initial guide to get you started. You have to give you some sort of ideas. So I was receiving quite a few emails about saying, I've done the programming, now I'm about to start task 3 and I'm unsure what this is, I don't know what this is, so this is a bit more sort of background into that sort of section. I'll leave it there for it, unless there's sort of particular points anybody might want to raise sort of right now, a typical sort of question, or you can ask me in the lab or something like that, or fire something off for us. Don't forget, if there are sort of common things that you might want to do or might want to ask, but don't want to be associated with actually naming that. There is, I think I put it on here. Yeah, there's a general feedback and request link. So if you want to give some anonymous feedback or an anonymous request, you don't want to sort of actually email it, you don't want to sort of be identified. Sorry, I've not brought it up there. There's a link on the top of the Moodle page next to the sort of lecture capture right at the sort of top, general feedback comments where you can just put a bit of anonymous feedback on what you think could be extra or a question that you don't really want to have sent or associated directly with yourself. It's obviously better if you just email me directly for that. Anyway, today's session, I'll say we've spent sort of quite a long on week 12, is this semantic technologies, things to help you communicate on the IoT. Labs again are about some sort of assignment help, some sort of lab catch-up for that. I'll certainly be giving at least another one for this. There'll be some other labs just on specific technologies like voice control and technology called Node-RED to try out. grid as well. But today's session is connecting things to the web. I won't probably be able to sort of get through all of this now after giving that bit of talk on it. Come on when you're ready. About once you've got this sort of sensor network together, so this should be sort of getting a fairly familiar diagram now. That looks just like the diagram that I have for my sort of sprinkler system, if you like for it, with these things running on low power devices and the like. We're looking here really a bit more on the communication of these, the things that the different ones do, what operating systems, what protocols that they got. We've had a look at some of those in the sort of task, and what different things might work out in terms of data aggregation. We looked at that the last session before the tutor week, where you might have nodes that bring together information from surrounding nodes, or like what the sync node might do. You might do some data processing on the node itself, deciding what information to send out and what and how often to sort of do it. The thing that we're going to have a look at today is this thing in purple there, for a bit more about the type of data that you transmit between these. Now, we've already done quite a bit of this sort of thing in the lab, where we're looking at transmitting, say, sensor data from your RFID capture or your slider capture or something like that, and sending across to a database to store. And we had a whole sort of collection of data to send. So these sort of sensors, if you like, we're trying to sort of bring them all together. And I'll just skip through this to get to the actual demo that I'm intending putting over. It's something that you'll be already familiar with. It may be that the sensor's sending a collection of information. For example, a sprinkler might be sending back information on what its current state is, whether it's open or closed, what the soil type is, whether it's dry or not, what's the local air temperature around it. You might be sending back a collection of sort of values, about 15C, 815, 53, and a -2 for it. And you'd need some way really of deciding, well, what are all these? You might sort of presume that that's slightly out of kilter. There's a value there, there's a unit of measurement, there's a time. You're using your own intelligence to interpret that the 15 is a value and that the C is a unit of measurement to it. But when it's received at the other side, it's not a human being that's receiving it, it's a piece of software that needs to sort of decide, well, which one's which out of that. And hopefully you remember in your labs from, I think that's sort of either week 2 or week 3, where we were sending data over, and it isn't necessarily always what you sort of think it is. So you could send over the data in a wrapper, in like an XML wrapper, for example, where we take a sensor reading and decide that every sensor's got a value, a unit, a time, a longitude and a latitude associated with it. You might need those last two to decide, which one's a longitude, which one's a latitude, because they're both just real numbers. Some people give it latitude, longitude, some give it longitude, latitude. So it's easier if you can give it a data wrapper that can specify what these individual components are for it. So having the two together might be sent across as a JSON stream. Now that's why in the lab sessions we created this sensor data. You've got a sensor data object to represent your sensor that you collected. What that sensor data object representation is up to the individual application. What are you trying to sort of send across to it? So that both sides in this case would know exactly what each individual component or each individual attribute actually refer to. So you'll need to build this into your your sort of system to have some sort of data markup for it, to represent what each one is. Currently, and again think about this for tasks 1 and 2, you might only be sending, say, single values. You might be just sending a message saying on or off to open a lock or something like that. But you might want to send a lot more sort of data. It might be information about a lock saying, well, who's the RFID tag, who's the user for it, what date this is authorised to. If you think of like a hotel key to open up a door lock, there's a whole sort of bit of information that you need to send to the sort of lock to make sure that it's valid, that the date's right, that your other tags might be available to sort of use with it. And we've got to have some way of representing that data block. It can be done in XML, been out for a long time sort of thing available. You can easily do an XML type structure. I doubt whether many would actually do the sort of XML structure in this for our sensors here. Not used widely for IoT sensors for it, but you might have that as a sort of sample there. You can also include things like attributes there, though. The good thing about using XML, it's a bit more descriptive than JSON. So you can add extra attributes like indicating what the value type is, that this is something given in decimal. You can do the same in JSON, but you just have to have extra fields if you want to say that the value given is a decimal value being sent, for example, or maximum values to sort of use for it. Most people, I think, are fairly well associated with XML and how they can be validated and well formed for it. But you might have, just jumping ahead, it doesn't really matter what the tags are that you use. There we've got one for measurement and value and unit. But you can define your own one there, sensor data, reading, and have your own sort of tag names for it. So you define your own XML definition for what these things look like, what an actual document is. Just flicking on. Yeah, I thought there was a JSON one in here. I must be missing it. No, I think I finished off just with that. It's equally valid that you would have this JSON string to do it. And the better marks in the assignment do assume that all the data transmission is done using some sort of wrapped up data, in this case of JSON. If you want to use XML, that's okay, just let me know and you say you want to send XML. It's a bit unusual to use XML with IoT, but JSON seems to be the most widely used one. But if you want to use XML for some reason, that's basically fine. So as long as you're using some sort of data wrapper to send it. Now it's not just sending the data to, say, the server. You might be saying, like we have in the lab, about storing some sensor data, and you say you have an attribute sensor data equals some JSON string. You can also send these as your MQTT messages. So the messages that are flying around the MQTT thing from the publisher to subscriber, you're sending multiple values, maybe wrapped up as that JSON string to sort of send. You can basically send anything over MQTT. It's not just about sending text messages. It's any binary object, basically. That's why when you send it, if you remember in a publisher, whatever you're sending, you get the bytes of it, and it sends a byte stream out. So any byte stream can get sent out around your individual nodes or your publisher and to subscriber, whichever, to sort of work with. So it's up to you what format you use. I'm suggesting that you use JSON to do it. Again, that's just following industry standards, what the bulk of the IoT world does. And that's why I'm trying to sort of push it in the assignment. If you want the top end marks, that's assuming that you're going to be doing that sort of thing, and it's built into the marking scheme for that, to sort of work with. Well, really, that's in this particular set. That's about all really that's going to be of use to you for your assignment. The rest of the information is about sort of IoT and its representation of quite vague data sometimes for it, where you might have to make things like vocabularies or how some of these objects relate to each other. There's this great word, ontological, for it. I think the word today for it. It's really how you define a particular vocabulary. What's your words that you're using to define a set of concepts for something? So you might talk about cars being a kind of vehicle for it. The sorts of things that you can use perhaps from your programming section about has-a and is-a type relationships for it. And if you're talking about sharing resources across the IoT world for it, we want something where, say, everybody agrees on what one of these things is. We are currently defining our own sensors. You're deciding this sensor data layout, and I've suggested one to you, and a lot of people are sort of making use of it. You can define your own sensor object if you like, but how does that fit in with other people then? So you may say, well, I've come up with this sort of nice little system to sort of work with it. I want to communicate with people who develop similar systems in other countries. Are we agreed across all these other people on what a sensor is? What's a sensor data sort of object? What is held in one of these? I might sort of say, you might have one word or one description of things that in a particular community means one thing, but in another community means something else to it. If I came up with, and I've sort of done something like this similar before, in one sort of particular community, if I said, what does that mean to you? There's somewhere in here, I think, certain Mr. Hines, who I've sort of been in communication with, and to his family, that refers to him. To it. Sorry, Ian Jack, by the way. Oh, sorry, Jack. Yeah. Sorry for bringing you to the fore there. To Jack's family, mention Jack, and it means, boom, that sort of person. Mention it in another community, you're sort of part of the Federation of Mechanics and Repairers of Cars, all of a sudden Jack means something else to it. Talk to another community, a sort of gambling community, car playing community, Jack means something else to it. It all depends on the context, it all depends on the community that you're with. It's got that's the reason I chose Jack, is because it's got something like, even in the dictionary, about 20 odd different meanings according to the individual community you're with, the context that you're in. Now, if we're talking about a sensor, it depends on who your community is. If our community is just the web and the mobile app development module, then we can all agree on saying, well, you've got a sensor data class, this is what we mean by it. But is it the same across everybody? Now, this is where we need to get sort of international standards out there to sort of agree on what's what for some of these. The Java community has agreed what a string is. The Java community has agreed on what an image is and what the different sort of attributes of those are. We need to get sort of an agreement on our vocabulary and what we call these primitives that we're using for it. Now, this is only typically feasible in a sort of closed collaboration to it. When you start getting outside, it gets a bit more difficult, and you have to start putting in sort of standards. And you have to have a fairly stable community to sort of work with on this. And this is where things like standards start sort of creeping in with it, to be able to define what some of these terminologies are and how they refer to each other for it. Now, what we're getting into here is a concept called the semantic web for it, where it's not just talking about individual objects that you might be searching for, but how they relate to each other to it. So, giving meaning
to it, and enabling or better communication between different people sort of working out for it. Now this semantic web has been proposed a good few years ago. That Tim Berners-Lee sort of put it out in 2001, but it's basically a better way to enable objects to work together, or finding objects and bringing those things back, by giving some sort of relationship between all these and how you embed that in the actual sort of pages. Just, I mean, for example, if you did a Google search for the word jack, you get all those different things coming out. So you get all the different approaches being sort of brought back. But if you can sort of work a bit more on the context and what they're related to, you end up with we've currently got this sort of syntactic web, where if you search for Tim Berners-Lee, then you probably get eventually to some sort of web page to it. But there's a whole sort of set of other references, links that come out with it. Like if you bring back the page on Tim Berners-Lee, yeah, you get this list of what Tim Berners-Lee's done and his links to sort of other ones. You just get these hrefs out, and that's, you know, we're used to working with that. And where this sort of problem might sort of come in is some sort of queries might be very difficult to do. If I said, for example, can you just do me a query that would find all images of Nick Whittaker, Darren Dancy, Paul Marsden? Great. And what would you might get individual ones in it, but are you going to get ones with the three of them together in it? That's a bit more difficult query to do. And although these three people are related in some ways to it, you're not finding something where there's images of them on the same page. Or, for example, try doing a more complex search. You've got your laptop out now, just see if you can do find information about animals that use sonar, but are neither bats nor dolphins to it. For example, barn owl, that uses a similar approach to it. Now you might think, yeah, I can do this, and I can just find animals that use sonar, but are neither bats nor dolphins. I think I've got one of those things up. Animals that use sonar but are not dolphins or bats.
With Google, you can put a dash in front of the word.
Yeah. Well, okay. I'm with you on that. Initially, yeah, you put in that first one. Animals that use sonar but are not dolphins or bats. So yeah, and there we get everything to do with dolphins and bats with it. Precisely the thing that we didn't ask for. So as my learned friend suggests, we can say without dolphins, without bats. Put the minus sign in front of it. You think, oh yeah, I'm smart enough to get it. And what do you get there? Not much to do with owls. Sort of coming out. I mean, okay, we know that the answer's owls, so we know what we're looking for. But it's just that these searches aren't really smart yet. They don't sort of have enough information about one thing being linked to another. There's no things like relationships being stored in. And that's a bit more about what this semantic web's about. We'll be having a look at this later on when we look at the problems of IoT and how difficult